Example 1 with these function word problems here. So the function h of t is equal to 256 minus 4t squared. It shows the height. So there we go. We're talking about the height in feet of a ball above the ground after it is dropped. And second piece of information, t is the number of seconds that have passed since that ball has been dropped. So just like our notes tell us, we're going to make a table of values to kind of help us show work here. And that's just going to be used with the calculator. So in your calculator, remember to graph things or to get the table of values, you need to go to that y equals first. If yours has blah, blah stuff in it like mine does, make sure you clear it out so you're starting fresh. And so remember, this h of t is really just like my y equals. And instead of using t, I can just use my normal x button because notice how there is a t variable there. That x button isn't specifically x or t or whatever. It's just a variable. So it's okay that your equation has t's, but you put x's in the calculator. So the 256 minus 4x instead of t, and then that squared button. All right, second and graph to get to the table. So now you might be wondering what kind of numbers would make sense here. And this is important to realize that when you're making your table, because t is the number of seconds, it's important that you realize that you can't have negative time. Right? You can't have negative 2 seconds. That's, it's either 2 seconds or 2 seconds before. You can't have a negative time. You can't have a negative time. Just like you can't have a negative distance. So when I'm writing down these table values, I'm going to start off where x, or where the t, is 0, because I can't have a negative time. So just let me get this scrolled a little bit better. And I'm just going to copy this table down right into my notes so I don't have to go back and forth. And again, like we said, this is how you show me that work. So I'm just going to kind of scooch this a little bit. And we're going to use orange because orange is fun. So we have an x value, we have a y value, but really this is an x, this is t. Not so much x. All right, so 0. Oh, geez, thanks. Cool, dude. Cool. Love it. All right, so 0, 1, 2, 3, 4, 5, 6. Looks like I'm going to run out of room. So 0 is at 256. 1 is 252. 2 is 240. 3 is 220. And the reason this is going to help us, it's easy to do it now and then just have it to help you later. You'll see. 768, 0. And so now thinking about this, if I keep going down, my next number gets me into the negatives. And so we're talking about y values that are negative, which isn't time anymore. Our y values were representing the height. And the ball can't go underground. So let's make some notes of that. So we can't have negative time. So we start at 0. And then down here, just like we've talked about before, can't have a negative height. So we stop at 0. That's why I stopped and started at those values. So we're going to use this table and stuff to make sense of what these questions are asking me. So part A wants to know what the 256 represents. Well, looking at that 256 is coming right from my equation, and it also shows up right here in my table with the value 0. So again, using what these things mean, we know that the y is talking about your height. The t is talking about time. So the 256 represents the height of the ball before it was dropped, because t is the number of seconds that have passed since the ball has been dropped. So if 0 seconds have passed, the ball hasn't been dropped yet. Excuse me while I die. Okay, moving forward. The 256 represents, let me start that again. The ball is 256. The height was measured in feet. The ball is 256 feet above the ground before it's dropped, aka your starting value. That's your y-intercept, aka starting value. Okay, part B wanted to know what is the height of the ball after 3 seconds. Okay, easy peasy lemon squeezy because I got my cool little table here. After 3 seconds, the ball is at 220 feet. Part C, how far did the ball drop between the 4th and 7th seconds? Well, 4th second, so at 4 seconds, it's at 192. At 7 seconds, it's at 60. So how much did it drop between those? Subtract. 192 minus 60 equals, I don't know, 132 probably. 192 minus 60. Look at me doing math in my head. So 132 feet. It dropped. Yeah, I said that backwards. It's fine. All right, keeping on here. Flying along. Next one, how far or how long does it take for the ball to reach the ground? Well, if it's height 0, this is it reaching the ground. So how long? That was an x value or a time of 8, so 8 seconds. At what second to the nearest hundredth is the ball exactly 100 feet above the ground? So this one, we are going to do a little math to solve this one, and I'm going to do this in a different video.